Welcome back to The Explainer. I am absolutely thrilled you're here today because we are setting the stage for a deep dive into a truly revolutionary shift in modern defense. We're looking at a technology that honestly feels like it was pulled straight out of a sci-fi movie, but it is very, very real. And it's rapidly reshaping how global militaries and security organizations think about protecting the skies. We're talking about the silent strike of radio frequency-directed energy weapons. Picture this. You're defending a protected airspace, and a massive, coordinated swarm of drones is inbound. But here's the twist. Imagine disabling that entire swarm without firing a single missile. Literally zero explosions. No bullets flying through the air, no kinetic impacts whatsoever. Just silent neutralization at the exact speed of light. Sounds impossible, right? Like, how exactly do you knock something out of the sky without physically hitting it?
Okay, let's dive into this. Imagine a highly cinematic, yet technologically accurate scenario where an active engagement is happening. You've got radar tracking, say 47 threat drones inbound, but the weapon itself, it's projecting a massive, invisible cone of energy, emitting a 2.4 gigawatt peak power beam. In a fraction of an instant, that burst of high-power microwaves successfully drops 23 out of those 47 drones right out of the sky. The drones literally short-circuit and fail mid-flight. And the wildest part? It achieves all of this without a single physical projectile ever leaving the launcher. Section 1. Meet the RFDEW. Grounding the science. It's time to peel back the sci-fi spectacle of this technology and reveal the underlying physics that actually makes it possible. So what does this acronym actually mean? RFDEW stands for Radio Frequency Directed Energy Weapon. The absolutely crucial distinction here is non-kinetic system. Traditional warfare relies entirely on mass and velocity, hitting things with other things. And RFDEW completely flips that script. Its primary effect is just energy. It uses concentrated electromagnetic energy to specifically target the internal brains of a machine. It disrupts, degrades, or completely fries the electronic systems inside the target, rendering it totally useless. To grasp how it does this, you really have to look at where these weapons sit on the electromagnetic spectrum. They operate right in the RF and microwave region, sitting right between standard radio waves and infrared light, usually anywhere from 300 megahertz up to 300 gigahertz. Now, unlike a laser weapon that focuses into a tiny, precise burning pinpoint, an RFDU fires a much broader beam. This is a huge deal because it allows the energy to wash over a wide area, engaging multiple targets simultaneously by frying their circuits with invisible energy. Which brings us to Section 2. Anatomy of a beam, deconstructing the tech. We know what the energy is, but let's peel back another layer to look at the massive hardware required to actually generate and control this invisible force. So how do we actually build this effect, step by step? First up, you need immense power generation. You're converting standard electrical power into raw, unbridled microwave energy. Second, a modulator takes that signal and amplifies it into high-power pulses. Third, and honestly, this is where the magic happens, is beamforming. You can't just let the energy scatter everywhere. You have to precisely shape and steer it. And finally, step 4 is the target effect, where that intensely focused energy washes over the drone, overloads its circuits, and completely disrupts its electronics. If you look inside the internal components of one of these incredible machines, you'll see massive power supply units and a pulse-forming network where the energy is stored. It is basically a giant electrical powerhouse. But the real stars of the show are the beamforming network and the high-efficiency antenna array. Those individual elements dynamically adjust the phase and timing of the signal. This means the system can actually steer and focus the beam in real time, tracking moving targets without even having to physically rotate the entire dish. It's literally steering energy on the fly. All right, Section 3, defending the skies, scaling up to infrastructure. The physics is fascinating for sure, but let's transition into how these heavy-duty machines are actually deployed in the real world to solve a massive modern problem: low-cost drone swarms. Think about the high-value targets we need to protect today. We're talking about everything from military bases and naval vessels to highly sensitive civilian infrastructure, like airports and power stations. So why are RFWs so attractive for defending these spots? Two main reasons. First, the economics. Firing a $1 million missile to shoot down a $500 drone is just mathematically unsustainable. RFWs offer an incredibly low cost per engagement. As long as you have electricity, you have ammunition, what the military calls a deep magazine. Second, their rapid multi-target capabilities mean they can engage a massive swarm at the speed of light, which is something traditional defenses really struggle with. And this brilliantly illustrates exactly what that defense looks like in practice. Imagine an RFDEW system stationed on a rooftop, projecting an autonomous 360-degree defense dome over a bustling international airport. The reaction time of these systems can be under 1.2 seconds. It can detect dozens of threats and neutralize them all simultaneously by washing that specific airspace with microwaves. It completely secures vulnerable civilian airspace autonomously, keeping the airport running without dropping any debris or explosives onto the runways below. Now, Section 4, the collateral catch, the dramatic pivot. I want to slow down our pacing here for just a second because we need a serious contemplative shift in this explainer. While this technology is incredible, we have to introduce the massive catch. The very thing that makes this weapon so powerful is also its absolute greatest liability. Let's look at the two sides of this coin. On one hand, you have the triumph of intended neutralization. You sever the drone's communications, its navigation fails, the payload is disabled, and the base is saved. Beautiful. But on the flip side, unintended disruption. You see, that invisible beam of energy, it doesn't know the difference between a hostile drone and a civilian airliner's navigation system. It doesn't know the difference between an enemy sensor and a local hospital's life-saving medical equipment. The terrifying consequence of an invisible beam hitting or scattering into the wrong target is profound electronic collateral damage. Now, what's really interesting about the split reality is how vividly this exact dilemma plays out. In an isolated environment, the system works perfectly, dropping threats safely. But deploy a widespread 2.45 gigahertz beam near civil infrastructure, that's a whole different story. The beam spreads, and suddenly you've got GPS degradation for commercial flights, communications jamming for emergency responders, and grid voltage fluctuations. This creates severe legal and ethical dilemmas regarding proportionality and distinction under international law. Deploying this in a city might save a building from a drone strike, but it could simultaneously shut down an entire hospital ward. Which brings us to our final part today. Section 5. Future Spectrum Warfare, the defining battleground. As we wrap up this explainer, we really need to look ahead at the geopolitical and military future of this deeply complex technology. I want you to really absorb this thought. As modern warfare becomes increasingly electronic and autonomous, control of the electromagnetic spectrum may become as important as control of land, sea, or air. That is the ultimate takeaway here. The future of defense isn't just about controlling physical territory anymore. It's not just about tanks on the ground or jets in the sky. It is completely about dominating the invisible battle space. Because if you control the spectrum, you control the enemy's ability to see, to communicate, and to operate. So what does all this mean for us? Will controlling the invisible spectrum ultimately save lives by neutralizing threats cleanly and cheaply? Or will the widespread use of high-power microwaves create chaotic new vulnerabilities in our own critical infrastructure that we simply cannot contain? It's a profound dual nature that is absolutely going to define the next generation of defense. Thank you so much for joining me to explore the fascinating, invisible world of radio frequency directed energy weapons. Keep asking questions, and I'll catch you in the next explainer.